This is my schematic. There are four components of interest here: the potentiometer, the DC motor, the servo, and the LCD screen. My Arduino of choice is the Arduino Mega 2560. This Arduino is great as it is essentially just a larger Arduino with more inputs, outputs, and grounds. I've also noticed that it has more support from Arduino and is an overall more consistent board to work with. Potentiometer. A potentiometer is a variable resistor. We can use an analog input to measure this resistance, and this produces a set of values. In real life, it's on a mount to simulate a gas pedal. In the schematic, it's as straightforward as a potentiometer goes: ground, power, and analog input. The DC motor. A DC motor is any class of rotary electrical motors that converts direct current electrical energy into mechanical energy. In this project, I use an NPN transistor to control the current going to the motor. A transistor is a semiconductor device that uses an amplifier or switch to control electrical signal and flow. If you want a more in-depth explanation, follow the link in the description to my video on transistors and logic gates. When the motor turns off, the electromagnetic field collapses and causes a current spike. To prevent the spike from damaging my components, I use a flyback diode. A diode is a one-way valve. A flyback diode is any diode connected across an inductor used to eliminate flyback. Servo. A servo motor is a rotary actuator or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. Basically, a servo is a motor that is exact and we can tell it to go to an angle and it will go there. There's a large variety of servos. This one can only rotate 180 degrees and is slow, small, and overall kinda sucks. The LCD screen. A liquid crystal display, or LCD, is a flat panel display that uses the light modulating properties of liquid crystals combined with polarizers. Liquid crystals do not emit light directly, but instead use a backlight or reflector to produce images in color or monochrome. Our LCD is small and doesn't have many pixels. We can only display text in a 16 by 2 grid. All the wires coming out look complicated because no one actually knows how they work, and you just have to plug and unplug wires until the LCD screen starts to work, as I did. As you can see here in the video, I'm moving the potentiometer within a specific physical range, and this controls the servo. Those go to specific angles, and then the speeds are on the LCD screen as well as the pot value. You can see all the wires, the mess of wires, and then this finally controls the speed of the motor. So you can see it slowing down, and then speeds up when I push down the pedal, and then slows down when I let off the pedal. Here's the code. Since this was a more physical components-based project rather than code, the code is pretty straightforward as far as my code goes. The pre-setup, so this section right here. This is pretty straightforward. It's just setting the pins and inputs, or the integers. It's allocating memory to the inputs and outputs that we later use. I include two libraries, the servo and the liquid crystal, or the LCD libraries, to use those components. And we create two objects, the liquid crystal, the LCD object, and then the servo 1 object. These are used later on. Now we get to the setup. We just begin the serial for printouts, and we begin the LCD, and we attach the servo. These three are just required to use the components. It's just more setup, and then we set the pins as outputs. We tell one of the pins to always be on and high. That's the motor power. And then we set the pins for the potentiometer, and we set the potentiometer power to high. Now we get to the loop. It's a fairly straightforward loop. It's mostly just numbers and manipulating the potentiometer. It is just manipulating the potentiometer reader to the values we desire, or I desire. So we first get the potentiometer, the analog input from the potentiometer. We map the potentiometer's range, which is 0 to 1023, to 0 to 1000. So a small change, but a necessary one, in theory anyways. Then we subtract 140 so that we kind of, there's a new minimal point that is 0. Rather than it being all the way turned, it's actually a little bit further up. And then we cap this so it can't go into the negatives. If the pot value is less than 0, the pot value is 0. Then we set the pot value. Then we multiply the pot value by 3.4. This makes that the physical range of my desired range is 1,000. So it was like 0 to 300. Now it's going to be 0 to 1,000, and then we cap off that value at 1,000, so it can't go above 1,000. Then we create a motor. The motor speed integer that we used earlier, we map the pot value to that range. So the motor accepts a range from 0 to 255. However, if the value is less than 150, the motor doesn't really spin that well because it kind of sucks. And sometimes I need to spin the motor so that it works. Then we analog write the motor pin. So we take the value and then immediately plug it in to tell the motor to spin at that desired speed. Next, we move on to the servo angles. So this little section right here handles the servo code. It yet again just maps the pot valve to 180, which is how many degrees we have, and then it tells the servo to go to that angle. Pretty direct relationship. Then we move on to the if and else if statements. So this is pretty straightforward. So we do use our custom little function. It's not very complicated. It just takes a string and then prints that string. This is done just so I don't have to have this piece of code over and over and over again. It actually saves a good amount of room, and we can have the if and else if on a single line format, which can be done if you only have one argument. One argument. So here are the ranges. It's pretty straightforward. Stop. So these are the speeds. So if it's faster than a certain speed, it's stop. If it's okay, that's good, fast, some speed, slow, and then if it's lower than a certain amount, then it just says stop. And then this just prints out the pot valve at the top of the LCD screen. So pretty straightforward code.